Welcome back, scholars, to another episode of Math with Marcus. This question is from Course 2, the 7th grade book from CPM, and it's about Proportions Web. And it asks you, so problem 60, 460 asks you, is the relationship shown in the table below proportional? If so, use it to complete a proportions web. So this is a proportions web with the constant of proportionality in the center, and that kind of drives the rest of our work here. And we'll do that in a minute. So first thing, is this relationship proportional? Well, the first thing to test is, well, would this relationship go through the origin? And in this case, if you don't work for any hours, will you excavate 0 dirt? Yeah, right? You're not going to dig up any dirt if you don't work for any hours. All right, so it does go through the origin. And then the thing to check is, does it increase by a consistent rate every time? So we're going to want to find this anyways. So if we find out, well, what would they be digging up each hour? So 3 hours is 6 6/10. So if we divide this by 3, that's going to be 2 2/10 cubic feet per hour. So if we times that by 4, you get 4 hours. If we times that by 4, do we get 8.8? Yeah. So every hour it increases by this consistent rate. This is very important. This is going to be our constant of proportionality. All right, it's our unit rate. So every hour, that is how much. Every time we dig for another hour, we dig up 2 2/10 cubic yards. Another hour, 2 2/10. Another hour, 2 2/10. Okay, so this is what we're going to do. So, woo. All right, not sure what happened there, but hopefully it doesn't happen again. So, this is our proportions web, and we've got our constant. I know it's a lot going on. This is not the cleanest one I've ever done, but in the center, you'll see that we have the constant of proportionality, right? Our unit rate. And up above, we've got the situation. So I just kind of explain the situation in words. So a person can excavate 2 2/10 yards, cubic yards, each hour of dirt. Can excavate that many yards of dirt, I should say. Of dirt each hour. All right, so the situation is just basically summarizing, right? Summarizing what's going on in words, so that people know what the rest of the problem is about. All right. The table down below we've already done, right? That if you worked 0 hours, you wouldn't dig up any dirt. 1 hour, right, here is our constant of proportionality. All right, 2 hours would be that, 3 hours would be that. So just a real simple table. Shouldn't take you more than a couple seconds. From the table, we can come up with our equation. You don't need to do this in this order, but for 1 hour, it's just going to be 2 2/10 feet. If it was 2 hours, we would times that by 2, so we would put 2 in here. So if we wanted 2 hours, we would just plug in the number 2 and get 4 4/10. If we wanted 3 hours, we could plug in 3 and get 6 6/10. If we wanted 12 hours, we could plug in 12, and 12 times 2.2 would get us the amount of dirt we could dig. So that's our equation. All right. And then our graph, you just want something super simple. So just 1 hour, 2 hours, 3 hours, 4 hours, and then 1 hour would be this, 2 hours would be that, 3 and 4. Just a very, very, very simple sketch with our constant of proportionality being right there, right? At one hour, we can dig that much dirt. So that's our proportions web, our proportionality web, our proportionality web with our situation, our equation or our rule, our table and graph, and of course, everything being based on our constant of proportionality or our unit rate. All right, tune in next time. Hope that made sense.